So any two vectors that are in the span of v1 and v2, where this is v1 and this is v2, is any linear combination. So I could put a 0 in front of the v1 and a 0 in front of the v2, so the 0 vector would be in the span. I could also, so I'm doing one option. Here's another option. You don't have to do all of these. Here's some examples. I could take 2 times v1 and 0 times v2. So just take this and multiply it times 2. Or I could take 3 times v2 and 0 times v1, and I get this. So there's lots of examples. In fact, there are an infinite number of vectors in the span of those two vectors. All right, must the 0 vector be contained in the span of a set of vectors? Yes, because you can put all of the numbers in front of the vectors as 0. That gets you to the 0 vector. So the 0 vector is always in the span of a set of vectors. Is this vector b, which is 0, 0, in the subset of R3 spanned by those two vectors? Wait a minute. No, this b vector is in R2. That means if I take this 0, 0, there's no number I can multiply times the first vector and multiply times the second vector to get from a 3-dimensional vectors to a 2-dimensional vectors. So there's no possible way. So let's just go. These are kind of just nitpicky. If it's not given that u is non-zero, what do you know about the span of u? Well, that means u could be the 0 vector. And what's the span of the 0 vector? The 0 vector. So it's just the origin. That's it. So it's really kind of too simple. So if it says that u is a non-zero vector, then the span of u could be a line through the origin. If it says u and v are non-zero vectors, that's good, in R2, and they're not multiples of each other. So if they're not multiples of each other and we're in R2, I could have one of the vectors here and another vector here. They're not multiples of each other and neither of them are 0. You can get to everything in R2 by taking linear combinations of those. So that means all of R2 can be reached by adding or subtracting those two vectors. If it is given that u and v are non-zero vectors in R2, but it doesn't say that they're multiples. So they could be multiples. So here could be u, the vector u, and then here could be the vector v, which is just 2 times u. So then that means that the span of those two vectors would just be a line through the origin. Remember, the origin is always included in a span of vectors because you can always put zeros in front of each vector. So if it's given that u and v are non-zero vectors, they're not multiples of each other, and they're in R3, what does that mean about the span of uv? Well, if I have 2 non-zero vectors in R3, so I'm just going to pick 2. If I just take a number times one of them and a number times another one of them, I can't get to everything in R3 because I need 3 vectors to span all of R3. So we don't know anything about it. If these are my 2 vectors, so they want the span of these 2 vectors is a plane through the origin. Remember, because we can always put zeros in front of the vectors. So this matrix A is this. So is B in that plane? And that's the same thing as saying, does that have a solution? And that's the same thing as saying, is this consistent? So the augmented matrix for the system is this, right? So we put the B right here, and then we do row operations. 2 times this first row, add it to the second row. -3 times the first row, add it to the third row. I get to this. And so now I want to multiply, before I do dividing, it be wise, think about multiplying row 2 by 4 and adding it to row 3. And that gives me a 0 here. Then I don't need to go any further because I see that this last row says 0 equals 2. That means it's inconsistent. So here we have to, we're looking for the value of h to see if the y value, if this y value can be written as linear combinations of those vectors, the v1, v2, v3. So here's my v1, here's my v2, here's my v3, and here's my y, right? Now I'm going to do row operations, multiply row 1, or I'm sorry, take row 1 and add it to row 2 and put it here. And then multiply row 1 by 2 and add it to row 3 and get it here. So then I get to that, and then I'm thinking, okay, I've got a 1 here, and I want a 0 here. So let's multiply row 2 by a -3 and add it. So I get to this. So what am I trying to do again? Oh, yeah, I want this to be what values of h will that make it in the span? So that means I need to make it consistent. And so it's consistent if h equals 5.